where, and mounds were done this way, it goes through the technical advisory committee at the state level, and they'll approve the specifications for it, and local health departments can still use it. It just won't be spelled out. Its specifics won't be spelled out in the rules. It'll be a special device approval. So the bottom line to that is it'll still be a technology we can use once it becomes available. It's just not in the rules. A few key definition changes from the first one. Alter and alteration has been spelled out, so it's been expanded. So that would also include any time a person is expanding the size of their house, so that we can look at altering the system to accommodate that additional flow. Average daily flow was added. All these years we've always looked at peak daily flow, and you all know that is 120 gallons per day per bedroom when we design a system. So 360 gallons per day for a 3-bedroom house. Well, probably just to be more clear about that, that system is really only designed to accommodate an average daily flow, not a peak daily flow every day. So the average daily flow is now defined as 60% of the design flow. 60% of that 360, which I think is about 210, somewhere in there. The sanitary sewer people use that same figure when they're designing sewers. Update. Well, they added a definition for update, and what that does is if you have an old aerobic treatment system, not terribly old, not 1977 old, but if we're talking something maybe that was installed in the 90s, early 2000s, it needs to be upgraded for some reason. Let's say something happened to the system and it needs an upgrade. It means that if you can add to that system, for example, we'll take a jet as an example. Let's say you just had a jet with an upflow filter, and now you can add re-air and UV and make it a compliant NPDES system. You can do it under this definition and under the code. So it's in the past there was some kind of uneasiness because people thought you're pretty much going to scrap that system, though it's relatively new, and go brand new. Now it allows you to update if it can be updated. So each system would be a bit different. Drainage or dry well has been defined, and really the definition isn't as important as a section in the law that says that we should not approve any drainage or dry well. Basically, they're tending toward becoming obsolete. Now, I personally told the state health department that I said, you don't understand. I've got a large portion of my county developed in the 60s through the 80s that have dry wells, thousands of dry wells. I can't, every time my inspector encounters a dry well, tell a person, you're done. I mean, that's just not practical. That's bad no matter how you look at it. So she said she understood that, and that as they fail, certainly we're going to replace them, and as they malfunction, we're not going to do things to rejuvenate them. Okay? There are some people who attempt to rejuvenate dry wells, and that's just no longer, that's a thing of the past. Because at the state level, they're saying they have to be done away with. The way we're approaching is they'll be done away with when they fail or they malfunction. Not every time one of you inspecting a property says, oh, it's a dry well. Yeah, we can't go there. That's just too much. So anyway, keep that in mind. Well, since you put gray water systems so extensively into this rule, they had to define what gray water is. And basically what this does is it dictates what fixtures in the house can go into the gray water system and what things cannot. So lavatories, bathtubs, showers, clothes washers, and laundry sinks that do not contain food waste, human urine, or fecal matter. So basically, no toilets and no kitchen sinks are allowed to go into the gray water system. And then it further defines what gray water recycling systems are used for. They went and also defined better what soil evaluator and designer mean. Now this is a piece, and we'll touch a little bit on this a little later. This is a piece where the legislature did not give authority to the state government to register soil scientists or designers. It just isn't there. Many counties wanted to see these guys get registered. Can't do it. State law doesn't permit it. So they did try to, though, say, okay, a qualified individual performing the service should have these qualifications. So they did as close as they could to registering them to make sure that they had a competent individual doing the work. Service provider was further defined, and the one probably operative word that we wanted to see added was evaluates. It means any person who services, monitors, or evaluates, because that brings you inspectors into the fold for evaluation of those systems. Flow restrictive layer was modified. You know, this, you might read through this definition and think it's just a bunch of gibberish, and some of it is, but it's very important. Some of these pieces are very important because they dictate the system cost. When there's a flow restricting layer that's shallow, what happens is what? It starts to get elevated or mounted up at the top of the surface of the ground. So what they say this means is very important because at the end of the day, it dictates the components that are used and the system's cost. And the one thing that everything's a change here, everything's the same here rather, except the red text, which basically previously said fine textured soils and clays. Well, they said, well, not all clays are so impermeable you can't use them. It's a shrink swell clay. That's what that number 2, that change has been. It's a shrink swell clay. That is very impermeable, and we don't want to be putting systems through that. But other fine texture soils may be usable. One change you saw back in 2007, and it's still the case, is highly permeable material. You know, back in the day, those of you who did do leach wells back in the day, you know, the quicker that sand and gravel, the better, because let's just get rid of the water. In the day, the sewage treatment system regulations were designed for disposal. Now they're designed for treatment and disposal, and you just don't treat wastewater well in coarse sand and gravel. So this piece is here to define what coarse sand and gravel means. A couple things to point out here. Number 1 there, anything that has 15% rock fragments and is in the loamy sand and loamy coarse sand texture. So if anybody is familiar with the Tyler chart, it's in the top row where those sandy materials are. Anytime there's 15% rock fragments, that's considered highly permeable. And what is a rock fragment? Well, it's spelled out in number 2 there. That's a fragment of stone that's 2 millimeters or bigger, so the size of grits or so, grit material. Other soils, number 3, is you can maybe have a more fine textured soil with large rock fragments in it. You can have up to 60% rock fragments in that soil, which is actually an increase. The old code said 50%. So if you get 60% rock fragments, you can still consider it a non-restrictive layer until that goes over 60%. Certainly you want to see soil between the spaces of the rock fragments too, not just chunks of stone. Fill material, that's been added just for clarification because we do see systems go into fill material. For example, mine spoil is a biggie. Once again, the limiting conditions are defined. Seasonal perched water table is defined, and I won't get into much of that except to say, now here again, if you were at the meeting, you probably didn't pick up on this, but this is a biggie to those of us who are concerned about system costs, and it's right here. 5%. Right now, in the old draft said 2%. So what that means is when the soil scientist is evaluating that soil, and they see, currently, if they see 2% or greater modeling in the soil, it's restricting. They bumped it up to 5%. So no longer that top layer where the modeling begins is restricting anymore. It's going deeper now. Because many of our soil reports say in the first lens of modeling you see will say 2 to 4%. Well, we have to call it restricting. Well, we can now ignore that layer and go down to the next one and hit it when it's at 5%. So this, again, these little changes will decrease system costs because it's becoming less stringent. Some terms that you're probably familiar with, but just a little bit different than what these are called here. Soil infiltrated loading rate is what we call today basal loading rate. If you get a site evaluation form, it says BLR, basal loading rate. This is the same thing, they're just calling it a little something different. So you'll probably see some changes on the form we use. Hydraulic lineal loading rate is the same as the lineal loading rate on the form we use. It's pretty much defined the same. The SILR defines the square footage of the system. So the number we use there defines the square footage, and the HLLR defines the minimum length of that system and how far that we need to spread it across the surface contours. Infiltrative distance. Again, if you've done this for any period of time, you probably know what this means already. It's the distance from where the effluent enters the in situ soil to the depth of the uppermost limiting condition. So the distance from the top of the native soil down to the limiting condition is called the infiltrative distance. Why is that important? Because the tables we use to define length in square foot use that term. Infiltrative surface is the point of application of the effluent to the soil or sand for the purpose of treatment. Okay, more terms. You might also think to yourself, why are we spending so much time on definitions? Because at the end of the day, when I have to make a decision, guess where I go? Definitions. Definitions make a lot of difference on how we have to interpret something. So, if you recall, the history has been up until 2006, almost every system had a curtain drain, interceptor drain, right? Then in 2007, they took it off the table. Now they put it back in. So, but there's a difference. What you are familiar with, that you've seen, if you've done this for any period of time, is a perimeter drain. A perimeter drain improves the site drainage, but is not necessarily designed to lower the seasonal perch water table uniformly. You're going to improve your site drainage by putting the curtain drain that you're all familiar with, that we always use, and that helps. But it is not an engineered drainage system. An engineered drainage system is much more along the lines of what farmers do to their fields. They are putting in fact, maybe I'll draw it. They're putting in drainage to more or less permanently decrease the seasonal water table. So if this is the surface of the ground, and this is where the modeling occurs. Or let's say that's the soil restrictive layer. Okay, and here's where the modeling occurs, the seasonal perch water table hangs out. Let's even put a leach trench in here. A couple leach trenches. When you install agricultural drainage, you define it by the depth that it goes and the distance apart that it's installed. And they're defined by the type of soils that you have. So here's my drain. This is my engineered drainage system. So what does this do? It creates a cone of depression. And when you engineer this, you want that cone of depression to uniformly decrease that water table so that you can now get a soil depth credit for doing it. The old perimeter drains didn't necessarily do this. They may have, accidentally. But now the engineered drainage system has to take into consideration more engineering instead of just slapping some pipes around and crossing your fingers and saying, I hope it doesn't. So that's what that's all about. So they brought it back so that you can use it, but it has to be done so that it actually does what it says it's supposed to do. Engineered drainage system. Any questions about that? What is the scope of the rules? Let's see, probably the most important part here. Okay, if you look at the third bullet down there, anytime there's an upgrade or additional flows, we have the authority to go ahead and have them improve the system if need be. The scope now incorporates sewage treatment systems as we all know them, but it also pulls in this whole gray water recycling system. And I should mention that top bullet, because one of the most common misconceptions about these rules and the past rules has been everybody's going to have to upgrade their system because it's not in accordance with the standards that are current now. That is not the case. We are not allowed to have somebody upgrade their system unless it is creating a public health nuisance.